Hey, thanks for subscribing to Welder Skills. This is TIG welding for beginners. This is a series of videos and it is aimed toward beginners, people who haven't really TIG welded before. Maybe they've welded something else but not TIG welded, or maybe you've never welded at all but you want to get started in TIG welding. This is aimed for you. You're in the right place. There's going to be a series of videos here covering things like process fundamentals, terminology, parts of the torch, how to hold the torch, how to get started, and all the way up to running that first bead. But it doesn't stop there. There's a series of skill exercises once you get to run that first bead that will guide you through getting better and better. Beads without filler, beads with filler, beads on steel, beads on aluminum, stacking beads on steel, stacking beads on aluminum, specifically designed to build the motor skills, the coordination between your torch hand, your filler wire hand, and your foot pedal foot, so that you can then welding things together and making things and repairing things, doing projects, things like that. So again, this is a series of videos, and the thing that I'm really excited about here at Welder Skills, we can do something we can't do on YouTube. And the number one thing is we can continually make videos better. So as comments come in, and I do encourage you to leave your comments. I'm going to be paying attention to them. As comments come in and I realize I left a little detail out, I left some, or I didn't address this or that, I can go back and change that video and just replace it with another video and keep all the comments there. I don't have to delete a video and then start all over, and then I'm going to continually make each video better until this video series will be the best one available anywhere. And that is my goal, to make this video the video that I wish I had watched when I was first getting started TIG welding. If we get those fundamentals down, then we don't have a ceiling on how much we can learn. Then you can learn that much faster, shorten that learning curve down, it'll be less frustrating. Let's do it. All right, I have unhooked all the torch and everything from this welder. It's a fairly basic welder, but has a lot in common with a lot of welders that are available today. So we're going to hook up everything: the torch, the ground, the foot pedal, the flow meter, the argon, and we're going to do a little quick leak check. Now, most TIG welders come with a pile of accessories like this. You see here a foot pedal, a pigtail adapter for 115 volt, TIG torch, ground clamp, flow meter, inert gas hose. This one came pretty much ready to weld. All I needed was a cylinder of gas, and that's going to be argon. For the most part, argon might be all you ever need. It just depends on what you get into. This is an owner's style, an owner's size argon cylinder, and that which means you can own it. There are usually limitations on sizes that you're allowed to own. I don't really know why necessarily, but the full size ones, the 300 and something cubic feet bottle, are generally only leased. And in my state, I can only own one this size. It's 125 cubic feet. But so far, I've kind of preferred to own them. They come with these protective lids on there. You want to keep that on there because it's a high pressure cylinder. You don't want to get it knocked over without this thing on there. I'm going to hook up this single flow meter to the argon cylinder. And I'm just going to leave it loose right now. I'm going to tighten up all these connections at the end, sort of. You always want to have your high pressure cylinders chained, either on your cart, on a wall rack, or something like this. So this is on the cart, and while it's on here, I want to keep this changed, except when I'm changing out the cylinder, and it should be empty at that point. Or if not, I want to put the cap, the protective metal cap, back on the top while I undo this. It's very important. Keep these high pressure cylinders chained up, keep them from falling over. Generally speaking, like I said, you might get one that's already got the fittings on it, but it might not. This one does, so I'm just going to hook this up. One end is going to hook in right here at the back of the machine. That's pretty typical. Might be in the center. This fitting might be on either side, but typically it'll be on the back of the machine. And this end will hook in the flow meter. I typically will bottom this one out. The seat, it's going to seat here with pressure from this thing, so Okay, now it's typically, I might want to put a tie wrap on here. For right now, I'll do that. We probably need to put a little soapy water on there, and we'll make sure that that's not leaking. I'm standing at arm's length. I'm going to open this valve nice and slowly. And once I see it register, I want to open it all the way and backseat the valve. You can lose a lot of argon overnight if you got a situation like this, so it's a good idea to leak check with a little bit of a soapy water solution. Sometimes you have to really kind of get on a wrench to get something seated properly to where there's no bubbles. It's important to leak check all the connections. You can lose a lot of argon. You can actually suck air in through these threads and have a problem there. So you want to get rid of all the little tiny bubbles, and sometimes you need a little hold back. Otherwise you could risk screwing up the connection inside the machine. Ask me how I know. I'm going to go ahead and put a tie wrap on this one. Most machines will come with a foot pedal. Some won't. There's also the possibility of a torch-mounted amp control. This is known as an SSC style foot pedal. And this particular one, I believe SSC company made it. But you got to get the right one for the right machine. If you don't have one, foot pedal will not necessarily work with another machine. So this is going to plug into the front of the machine right here. Here's the reason I'm doing this first, is because all this other stuff would be in my way and there's just not a lot of room to get your hand in here. Okay, notice we've got electrode negative here and positive here. The ground goes into the positive, the TIG torch goes in to the negative, the side that's got the little TIG torch icon. This is my TIG torch here. This is the DINS connector. With the DINS connector like this is the CK worldwide DINS connector. If I want to swap TIG torches, cable and all, it makes it very easy for me to do that. Basically, I just all I need to do is undo this torch cable, put another one in, and I'm good to go. I probably should have put the argon in first, and so I'm just going to do that. It's so easy to take it in and out. I'm going to go ahead and take that out, and I'm going to go ahead and screw my argon hose in here. My ground cable. You'll want to make sure to attach your ground to your table or work surface in an area that doesn't have mill scale or paint or any kind of coating. So those are the basics on setting up a TIG welder. All machines are a little bit different, but they're all similar. Now let's take a look at basic setup for TIG welding steel on DC. Biggest thing I want you to notice is this TIG torch icon. Very important. Extremely important to hook up your TIG torch to the correct plug, the one with the TIG torch on it. In this case, it's negative. Most of them are negative, but always look for the TIG torch. That's hugely important. You can really screw up by not doing that, and the reason I say that is because it will still weld. It'll just make you chase your tail. For steel, we're going to use DCEN, direct current electrode negative. And that's going to give us a very pinpointed arc, because most of our heat is going into the metal, into the workpiece. And that lets us keep a sharpened electrode and really put the heat exactly where we want it. So the basic setup for TIG welding steel, you just want to be on DC. You want to be on remote, so that puts your foot pedal into the equation. Pulse is off. The stick TIG button to TIG. And then now, the only thing that we need to worry about in any of these knobs is amperage and post-flow gas. And we'll go ahead and set it on their sweet spot to start with and go from there. And then amperage. Amperage is very dependent on material you're welding, thickness, and a lot of other things. There's no one rule of thumb, but there is sort of a guideline. And up to about 125 thousandths thick for steel, 1 amp per 1,000ths of thickness will get you in the ballpark usually. So if I was welding 1/8 inch thick, that's 125 thousandths, 125 amps. I'd be full pedal at some times. Here's a clip of welding 125 thousandths thick cold rolled steel. And I'm probably fairly close to being full pedal here, probably somewhere between 115 and 125 amps. You can see me tapering off using the foot pedal to use less and less amperage as I end the weld. But that would be a guideline for me. I might want to just go ahead and set it up to 140 and have a little bit extra. If I was welding something really thin, you know, box cutter blades or something like that, I might be down around 25 amps, and because they're only about 23 thousandths thick. You could leave the machine set at high amperage and just work it with the foot pedal, but it gets kind of tricky sometimes. If your ankle pops or something, you can get 20 amps all of a sudden, and on box cutter blades you just don't have as much forgiveness, much leeway as you do on something thick. So it's good to set it in the ballpark of what you need with just a little bit extra amperage. So 1 amp per thousandths of thickness is a fairly good rule of thumb if you just have no idea where to set it, but it's not completely accurate. And it goes haywire when it gets thicker than 125 thousandths. A little quick review then. Okay, one quick review. We're not worried about AC frequency or any of these because that's only for aluminum on AC. We're not worried about our pulse settings. So really the only two things we're worried about are amperage and the post-flow gas. Make sure I'm on DC, make sure I'm on remote so that I have amperage control. My pulsar off, this switch set to TIG, boom. If I've got that remote turned on and I press this foot pedal, there's a solenoid valve inside the machine that the foot pedal actuates, and so I get current and gas flow all at the same time. Alright, I'm going to remove the ground clamp here just for this little quick demonstration. And I'm going to press the pedal and you'll see the high frequency current that initiates the arc. You'll also hear the argon kick on at the same time. This is called the post gas or post flow, and basically it's in increments of seconds. And so if I put it on 10 seconds, that means the argon is going to continue to flow for 10 seconds after I let off the foot pedal. Right now it's only set on about 5 to 6 seconds. 1,000, 1,000, 2,000, 3,000, 4,000, 5. We're getting close to getting ready to weld, but first let's take a look at TIG torch parts, electrodes, and how to cut and sharpen.